Welcome back again, Advanced Functions, Polynomial Functions unit. In this lesson, lesson number 4, we're going to talk about transformations of power functions, specifically for cubic and quartic functions. First, let's go over cubic functions. A cubic function has a function representation of x to the power of 3. And after all the transformations, this is a summary of all the transformations that are included. So we will be representing A and D as a vertical transformations and B and C as a horizontal transformations. So if I were to map out a cubic function, it will look something like this, has 0, 0 as well. So the key points that you have to remember in order to apply the mapping rule for my parent function for f at x equals x cubic, so you can plug in -2, -1, 0, 1, 2. So I will be plugging -2 into x. You will get -8, -1, 0, 1, and 8. Now, when I apply this into a mapping rule, so the mapping rule is, when do you use it? Well, you use it when you want to figure out how the transform function will look like from a parent function. So the mapping rule from xy, which is my parent function, it will look like AD affects vertical, so AY plus D. And then for horizontal, it will be, you always think opposite when it's inside the function of cubic. So you're going to flip B, which is 1 over B, x, and then you're going to flip in terms of opposite sign. So it's going to be plus C. So that is the mapping rule that you have to remember in order to figure out when you want to look at a final transform function from a parent function. So let's do a quick overview. So f at x is equal to a bx minus c cubic plus t. Now for a, you're going to look at two things: a sign and the value. If the sign is negative, so if a is less than 0, then we say it's a vertical reflection through or in the x-axis. But if it's positive, then the graph is just itself. There's no reflection. Now we're going to take a look at the value. So I'm going to put an absolute value. So if a is greater than 1, just looking at the value, we say it's a vertical stretch. So I'm just using acronym, and by factor of a. However, if my a, absolute value of a, is less than 1, meaning it's in between 0 and 1, we say it's a vertical compression by factor of a. Okay. Now, also, if I want to look at b, it's the same idea. For b, we will be looking at a sign and the value. If b is less than 0, this time it's a horizontal reflection. So it's a horizontal transformation where reflection in the y-axis. Okay. Now, if the value, I'm going to take the absolute value of b. So before I do absolute value, I'm going to write in in a red letter saying for b, for value, you gotta flip it. So what I mean is you are going to, when you flip it, in this example, it's going to be 1 over b. Okay, so we're just looking at the b value. So therefore, it's going to be, if b is greater than 1, then it's a horizontal stretch by factor of b. But if absolute value of b is less than 1, meaning it's in between 0 and 1, it's a horizontal compression by factor of b as well. Now let me show you an example how to understand this. So for example, if I were to have y is equal to 1 over 3 x cubic. So 1 over 3 is under the cube, so this is going to be my b value. So what you have to do is first, you have to flip it. So I'm going to flip 1 over 3, so it becomes, my v value is 3. So therefore, because it's greater than 1, we say it's a horizontal stretch by factor of 3. Okay, so I'm just writing in simple terms. Okay, so make sure you flip it for anything inside the function. Next, let's take a look at translations. So we have c value here. So again, if the for c, you have to think opposite. So I'm going to write in capital letter opposite sign. So if c is positive, meaning it's greater than 0, it's going to be a horizontal translation by right 3. However, if c is negative, meaning c is less than 0, then it's a horizontal translation if left 3. Okay. Now, lastly, we have letter D. So D represents a vertical translation. So for D, you just read it as it is. So if it's positive, that means it's greater than 0. Then it's a vertical translation for up D. And then if it's negative, meaning less than 0, it's a vertical translation down D. Okay, sorry for the writing. So it's down D. Okay, so we did this in the previous chapters for functions. So this should be a review. So let's try some questions here. So use the transformations to graph each function. So ideally, I would like everyone to understand how the transformation is being done from original function. So my parent function is going to be a cubic function. So as you can see, the negative tells me that there's a reflection in the x-axis. And we also notice that the a value is greater than 1. So we say it's a vertical stretch by factor of 2. Okay, so I'm just writing acronym as just simplicity. So I'm going to plot the original functions, 1, 1, 2. Okay, so it's a little bit out of the line. It's just here. So this is my parent function. Okay, don't forget the arrows. And y is equal to x cubic. Now what I'm going to do is I'm going to first do a reflection, x-axis. So if I were to do a reflection, this will reflect here, this point will reflect over here. 0, 0 stays the same. It reflects here, and 2 over here. So this will be my just a reflection through the x-axis. And we will be stretching by 2. So if it's stretching by 2, that means it's going to be a little bit more narrow. So therefore, if it's 1, 1, this 1 will become 2, and this 8 will be, oh, it's a little bit out of space. Yes. So you'll notice that it's a little bit more stretched vertically by 2 times over here. And I would label this as f at x equals negative x cubic. Now, if you want to know more in greater detail, you could do a mapping rule. So for example, I can show you this. For mapping rule, my original point, -8, -1, 0, 1, 2. So for my x value, it's just going to be x because nothing is affecting the horizontal. Then it will be -2y. So x stays the same. Now what I'm going to do is I'm going to apply -8 into y. So it becomes 16, 2, 0, -2, and -16. And you can double check. So 0, 0, 1, 2 for the green one, and then it will be the double of 8, which is -16. Okay. So mapping rule, it's an exact way of identifying the transform function. But in this unit, you should be familiar by being able to draw approximately from a parent function. Let's do another practice. So we are given a transform function here. So let's write down some transformation. So we have reflect through the x-axis. And then we have c value. So again, it's positive 2. So when you take it out of the bracket, it becomes -2. So that means it's a horizontal translation, left 2. And then finally, d is positive 3. It's a horizontal translation, up 3. Okay, now same thing. I'm going to draw -1, -1, 2, 8, to -8. So it will look something like this going in and then going out. Make sure you label x cubic. Now, as always, you start with reflection first. Reflect through the x-axis, which is this one, this one. This becomes over here, and -8, 0, 0. Okay, so now still same curvature, but it's been reflected. Now we're left with just a translation. So what we're going to do, we're going to move each point by left 2 and up 3. So for example, if I were to start from the center, left 2, 1, 2, and move up 3, 1, 2, 3. So this is going to be my 0, 0. Again, for -1 and 1, I'm going to move left 2, 1, 2, and up 3, 1, 2, 3. Okay, and then same thing, left 2, 2, 1, 2, 3, and same thing, 1, 2, 1, 2, 3, and somewhere over here, further. Okay, so now we have draw the same curvature going out here, and this will be going in this way. Okay, so that will be my final function, the transform function of f at x negative x plus 2 cubic plus 3. Okay. Now let's move on to a quartic function. So quartic function looks very similar to a parabola, but you will notice that it's a little bit wider because it's exponent of 4, and the final transform variable looks exactly the same as a cubic, but this time the exponent will be 4, and it's a parabola U shape that is wider. Same, so use the transform function to graph each graph. So letter A, as you can see, let's write down. So negative, it's outside the quartic. So that means it's a reflect through the x-axis. And our C value is negative 2. So when you take it out of the bracket, C becomes positive 2, meaning it's a horizontal translation, right 2. Okay, so same thing. So let's plot the parent function, 0, 0. So we can write down y is equal to x4, xy. So we could do negative 2, negative 1, 0, 1, 2. So we're going to plug everything in. So 16, 1, 0, 1, 16. So it's a little bit tight. 0, 0, negative 1, 2, it will be somewhere here. Okay, so I just want you to understand how it will be stretched and reflected based on the original. So this is my y is equal to x to the 4. And then if I have to do a mapping rule, it's going to be x plus 2 because it's moving to the right 2, and then negative y. Okay, so I'm going to plug a negative 2 into x, which becomes 0, 1, 2, 3, 4. And I'm going to plug in negative 16 into negative y. So negative 16, negative 1, 0, negative 1, and negative 16. So let's see. Now we are going to plot the points. So 0, negative 16, so it's right at the bottom. 1, negative 1, 2, 0, 3, negative 1, and 4, negative 16. And this is my transform function. Now it makes sense because if I were to flip this one through the reflection, through the x-axis, that means it's going to look like this. Okay. Okay, so reflection first always, and then we have to move right 2 steps, which is the blue final graph. Okay. Lastly, we are given 2 minus 3. Now keep in mind this is a little bit different because it's usually it's x minus a number and then cubic or quartic. But this time it's 3 minus x. So I would recommend to rearrange so that x comes first, negative x plus 3, 4. And I could technically move this 2, and then it will be negative. And you don't ever want to start anything in front of x when you have an expression in the bracket. So you must factor out whatever it's in front of x, so which is negative bracket, factor negative x minus 3, and then 4 plus 2. I just moved 2 to the back so that we could see that the d value is the same as whatever it's in front of 2. Okay, now let's see. So we have double negative here. So for the first one, we have reflection through the x-axis. And then the inside the bracket represents that it's reflection through the y-axis. But keep in mind that negative is negative of an even number. What happens? It turns it into positive. So therefore, f at x is equal to, it's negative, bracket, x minus 3, 4 plus 2. This is exactly the same. And I would recommend you guys to simplify it because negative inside the even number, it always turns it into positive. Okay. So therefore, I wouldn't say reflection through the y-axis. So we are looking at over here. And then we have a c value, which is, again, you flip it, it becomes positive 3. So it's a horizontal translation, 3 right. And then we have d value, which is 2, horizontal translation, 2 up. Okay, so let's draw the original function. 0, 0, 1, 1, negative 1, 2, 16, assuming that this is at 16, and negative 2, 16. Okay, good. Now let's do all the reflection. So if I were to do a reflection through the x-axis, so reflection first always, and then transformation and translation. So it should be symmetrical. Okay. And now we are going to move 3 right and 2 up. So I'm going to move the center vertex, 3 right, 1, 2, 3, and up 2. Same thing, all the points, 2, 3, up 2, 3, up 2, 2, 3, up 2. So it will still be over here. And then it will look something like this. So translation should be your last step of moving up and down, left or right. So f at x is equal to 2 minus, I would write down the original function. Okay, that's that. Now we have a different type of questions. So right now we know that the function, the parent function is x to the 4. And these points are the transformed functions. And they want us to write down the equation of the transform functions. So first, let's identify the parent function for y is equal to x4. So it will be negative 2, 16, 0, 0, and 2, 16. The reason why I picked 0 and negative 2 and 2, as you can see, we're given, it skips 2 steps. So 0, 0, and then the next point should be over here, but it's very vague. So what I'm going to do is I'm going to step one more time. So I'm moving 1, 2 steps. So that's why I decided to use negative 2 and 2 as my parent function. And now the transform function, which we're going to find out, but we know that when we're looking for a transform function from a graph, there's A, B, C, and D. But we always ignore B. Okay, we're only looking for A, C, or D because B could be interchanged with A. Okay, so therefore it's going to be X plus C, AY plus D, assuming that it's coming from our original functions that we studied, X minus C plus D. Okay, and then let's write down the points, -1, 2, 1, -2, and 3, 2. So as you can see, they're correspondent to one another. So I'm going to use a center point 0, 0 for my first equation. So unfortunately, for C, if I were to plug it in, 0 plus C equals 1, it will give me a 0 plus C equals 1. So I'm plugging X as 0, then C is going to be 1. So it works perfectly. Then let's see, I'm going to plug in AY. So A, Y is 0, plus D is equal to -2. So A and 0, unfortunately, this cancels out. So D is equal to -2. Okay, now we can definitely use the second point over here, 216. So 216, let's use this. So to figure out the value of A. So 16, A is A times 16, which is the Y, plus D is equal to 2. Well, we already know D is going to be -2 from here. So 16A minus 2 is equal to 2. So move isolated, and you will get A is equal to 1 over 4. Okay, so we have everything. Therefore, let's put everything together. Y is equal to 1 over 4. Now C is 1, so when I put it back into the bracket, it's going to be opposite sign. So it's X minus 1, 4, right? And then minus 2. So that will be my transform equation from a graph. Okay, so lastly, so we're given a cubic function and it will go through this following transformation, and they're saying that it passes through these 3 points, and they want us to list the coordinates of a transform points. So let's see. So let's identify all the x and so y value. So reflected in the y-axis. So let's do the mapping rule. So it's going to be 1 over bx plus c ay plus d. So reflected in the y-axis and reflected in the x-axis. So that means it's going to be negative for x, so negative, and negative for y, and negative for x. And then horizontally stretched by factor of 2. So that means it's going to be negative stretch, so b is 2, and then vertically compressed by factor of 1 over 2. So compressed means 1 over 2, and vertically translated 3 units up. So that means it's going to be d plus 3. Okay. So now what we can do is we can plug this points, -1, -1, into our mapping rule. So I'll be plugging -1, -1, 0, 0, 2, 8 into my transform function. So when I do the calculation, so -2 times -1, it will give me 2. -1 into y, when you evaluate it, it will give you 3.5. 0 times -2 is 0, becomes 3, and -4, and plug in 8, it will give me -1. So therefore, what are the transform function, the points, the coordinates? It's going to be 2, 3.5, 0, 3, and -4, -1, respectively, from the given question.